cracked everyone is here in terms of the engineering background. And yeah, really excited. So I would call these folks up. Please take a seat. And we're going to do a panel session. So I'm going to ask some questions that gives a chance for us to kind of merge the different perspectives. Please choose your seat. Yeah, this isn't Squid Games. It's yeah, no clicker needed. This is where I get to decide if I had enough chairs. I'm also going to be the one asking questions, so I'll switch my hat. All right, so thanks for joining. Thank you, John. Do you want to introduce yourself briefly, as I know you didn't speak personally?
Sure. So I joined Grok in 2018. Before that, I was at Google as a product manager. I, in fact, worked with Chris there a little bit. I was the product manager for GPUs and TPUs in Google Cloud. And I spent a couple of years at Amazon, like you mentioned, did robotics, and also in AWS for a little while. So my background, like you said, is mechanical engineering, but I've been doing product work for quite a while. And I'm happy to tell you more about Grok as well, but I'm sure questions will come up. So
cool, thank you. Okay. And I didn't know you two had worked together initially.
Briefly,
so again, it's kind of like when you have influential people, you realize it's all the same group.
No, John's amazing. He made cloud TPUs actually get out to the world instead of just being an internal Google thing.
Thanks.
Cool. Well, so the first question I'm going to open with here, and the structure is I'm going to ask a couple questions. I'll let you guys ask questions to each other for a little bit, and then we're going to let the audience ask questions. We're going to do all three. So my first questions is, everyone here's talked about an ambitious problem you're trying to solve. You're unified by compute, it seems like, at least, or hardware, the hardware problem. And we have a room full of glorious builders who contribute across code, investing, everything. How does this group help you win? So concisely, what is the biggest block you face from your perspective? And how can an open community help?
I can go first briefly because the last question I tackled addressed this, and the answer is don't continue feeding the system that is not working, right? Like I mentioned earlier, cloud credits are great until they're gone, right? And then you're locked into one of these providers that is exacerbating the problem. So don't continue feeding the system. You all have individual agency, a lot more than I think you may realize. And I really appreciate that you all are here, and I see many people with a golden lanyard, which means you've decided to take a big leap and build something, right? I encourage that. The other thing I would say is, we're talking about democratizing intelligence. I talked about the stack. We need innovation at each of those layers. Obviously, you're working at that lowest layer at the chip level, but Grok also has a Grok cloud, right?
And we're actually working at most of the layers you mentioned there. Right. Yes, I can talk about that when you.
So actually, let me pass it to you. And so you're an example of how you don't have to be a hyperscaler to impact more than one layer. And so, yeah, I don't know if you want to.
Yeah, so I think the way that would be most helpful for Grok that people can do here is to basically start using our tools and give us feedback about what works and what doesn't work for you. So Jonathan Ross is our founder, and he identified kind of the complexity. He also worked on the original version of the TPU as well, and recognized that the complexity of the systems for acceleration were kind of preventing acceleration from increasing, and it was increasing cost, power usage, and things like that. And so what we're trying to do at Grok is simplify that as much as possible. And I'd like to talk about that a little bit more, but just to answer the question quickly, and especially from a product perspective, I'd like to understand what people are trying to do with Gen AI and how we can help improve that. And we're trying to reduce the amount of power required. We're trying to reduce the cost of that. And so if we understand the use cases, and especially the valuable use cases that require a lot of compute, how can we simplify that, make that faster and lower cost for you? That's kind of our goal.
So I'm going to echo on that. So SiliconData, we're not actually we're not providing any GPUs. We're not building any chips. Can you hear me? We're coming from a very third-party data benchmarking point of view. So for us, we love to see a vibrant ecosystem from the lower layer, right? Even from TSMC, right, to the chip design houses, to all the way to models. I think that's a market really need, and everyone has choice. And then things can, hopefully things will accelerate even faster speed because of the vibrant marketplace. And for us, is we want to provide transparency to you, so that you should know when you negotiate cost structures, negotiate terms, you can hedge out the price fluctuation, you can have the carbon, so you have the transparency. Then it's up to you to make a decision. Where do you want to put the data centers at? How do you want to hedge your prices? How do you benchmark the GPUs? And then things just be more efficient, more flexible, and the whole industry can grow faster, at least a healthy speed. Now versus everyone is struggling either with on cost side or fluctuation side or just lack of visibility. That's something, I think it's going to really hinder the industry growth.
Yeah, I mean, from my side, what I love to see is people zig when everybody else is zagging, right? And so the hyperscalers are generally brute forcing things, like whether it be teams of hundreds or thousands of researchers or whether it be ridiculous amounts of compute. So I like seeing things like the DeepSeek work that just recently got released, where with constraints comes innovation. And so what I've seen a lot of, particularly in the AI space over the last 5 years, is a lot of consolidation. Like everybody, not everybody, but too many people are thinking the same way, approaching problems in the same way. I love seeing like the linear context approaches and the SSMs and things like this, even though transformers are dominant right now. Because at some point, there'll be something that goes beyond this. That'll be a massive breakthrough. And I think that we can't get there as a community if everybody's just doing the same thing. And so one of the things I love about the field, and it gets back to the feeling of openness and innovation and inclusion, is if we can break down the barriers, we can get more people involved, we can get new ideas into the ecosystem, we can go test things faster and then throw them away if they're bad ideas so we can pursue the good ones. And so this is the thing I love about this time, is that there's so much energy and there's so much potential, and it's just the consolidation that makes me a little bit grumpy.
I gotta ask, because you said zig when others zag, and you're a programming language designer. You know where this is going. What do you think about zig, the programming language?
Okay. So I love all of the things. I love them for different reasons, and it depends on what your goal is. If you want a better C, then zig is a very nice better C. There's things I don't love about it in terms of memory safety and things like this, but again, to your point, it's innovation. Right? I love the fact there's a community of people with like minds that come together and build that thing. Mojo's way cooler. Mojo has comp time. Mojo has better syntax. There's all these things that Mojo's better for, but Zig is great at things that Mojo doesn't do. And so there's there's room for innovation, and not everybody. It's not like winner take all here, right? So different things are trying to do different.
Thank you. I saw your reaction, because I know when somebody like you talks about a programming language, it's all over the message boards. IRC is going to be talking about this for weeks.
Well, so it's also, I wear many hats, right? And so with my LLVM hat on, I love the Julia and Rust and obviously Swift and Clang and there's a lot of languages out there that are really awesome.
Thank you.
They have great community.
One more question I'll ask openly here. So you're all later stage leaders of teams and initiatives. You're really good. I know you're all really good at communicating. I want to put you on the spot respectfully and say, imagine you win. It's 5 years from now. You succeeded in your mission. As concisely as you can, what does the world look like now when you've won?
More people using more hardware in more innovative ways.
Super high performance inference at very low cost.
We've dropped the price of the complements of intelligence to their commodity level, and as such, everyone in this room and in the world is able to access the resources that they need in the output of artificial intelligence at close to zero cost.
And then everyone can hedge whatever risk they want to hedge, different durations, different data centers, different chips. They can benchmark everything. Everything's supposed to be very cheap, nicely, easily done.
I love it. Yeah, you guys know I didn't tell you the question ahead, so I always respect how well, if you're a founder, take that as a really good example of on the spot in a social setting, how well you can articulate what your vision is. This is why they lead teams of hundreds of people. I want to actually let you four ask each other a couple questions. If anything has come to your mind now that you've heard some of you speak, are there any questions you want to ask to others up here? You don't have to, but while you're up here with your friends in adjacent verticals.
I can go first. I have a question for my friend here, from Grok. So I actually ran into Jonathan at Davos. He was asking me a question on the street. He was like, "Can you point me?" He doesn't know who I am. "Can you point me to where the dome is?" It's an MIT reception. So that was nice enough to help him out. I was like, "You look familiar." That's pretty funny. So Grok is definitely one of the leading, I would say, inferencing design house for chips. Obviously, you guys do a lot of different things. I'd love to hear more about the Grok Cloud, your partnership with some Saudi agencies, and what's your, I guess, the 2025 plan?
Sure. I'll start with the Grok Cloud, and you pointed out that we're a very good chip design company, but it's interesting because we actually have high-quality engineers at every layer of the stack that you were talking about. And one of the things we realized is because the Grok chip is different, in order to get that in people's hands, if we could provide a cloud with an API, an OpenAI-compatible API, people could start using it immediately and kind of enjoy the benefits of the high performance. One other thing I'd point out that's kind of interesting is our chip is super fast and low power, and it's a 14-nanometer chip, where all of our competitors, except NVIDIA, are at 5 nanometer, and NVIDIA's at 4 nanometer, moving to 3. So we actually are using kind of old technology to get this high performance. So we have a great, kind of full stack team. We have people that really understand how to write compilers, and people that understand how to get the LLMs running on our system. The other thing about Grok, so when I was thinking about democratizing intelligence, one thing we've done at Grok is try to simplify as much as possible. Simplify often reduces cost and power usage and things like that. So for instance, I know, especially when I was working at Google, we would find, I think it was the Broadwell chip that Intel came out with, and then same thing with some NVIDIA chips, that people were finding bugs in those chips when they were in the field. Of course, people are moving fast, so it's not too surprising. But if you look at the chip itself, it's super complex. They have multiple clocks running across the chip. They have multiple levels of cache. And in fact, what we've done in order to get high performance on chips is to give the processor itself control over what happens. So the fact that we're using caches at all means that we, just get it where you need to get it from, and we'll put it in the fast memory when we think it needs to be there, right? But the compiler doesn't really know anything about this. So much complexity on the chip level. On the compiler level, also, right, when you put in the code, like early when I was programming, I tried to optimize it, but then I didn't realize the compiler could optimize for me, and he's responsible for a lot of that. But so what we do at Grok instead is we have a very simple chip organization. In fact, the control circuitry on the chip is maybe 2% of the whole chip, whereas in a normal chip it might be like 20% or something. And we do all the control from software, from the compiler side. And in fact, because of the high-speed chip-to-chip connections too, we can scale up to a large scale, 10 racks, 100 racks, to run models simultaneously. And because we have a lot of SRAM on the chip, we can put all the weights in SRAM. And that means we can just run everything with complete control from the software side. So, like you said, we're working at the chip level, but that was just one ingredient of all that we needed to get high performance. I know I didn't answer both your questions, but I took a lot of time, so I wonder if I should let someone else go.
I want to ask Chris, because I really respect a lot of what you've done, and I often get the question as a multi-time founder, how do you recruit talent? And I want to be extra precise with my question. I briefly talked about the comp you get at a lot of these big companies, and in some cases with the crazy valuations, truly, that we're seeing for companies that have existed for less than 2 years, some young people are making a lot of money and retiring, and the talent that they have is being taken off the market. Now, I'm hoping that's just an aberration. They get bored and they come back. But how do you get the best people?
Well, so that's a really broad question. So it's also not completely new. If you go back to Google in 2017, 2018, it was almost a strategy to just hire all the people in AI. And that the AI field got too big at some point for that strategy to work, but that was kind of a way of just depriving the industry of talent because ad systems are so critical to Google and things like this. So for me today at Modular, I think it's a combination of two things, right? So one is we do pay high salaries and we do need to be competitive with a big tech kind of salary. But also, people are mission driven. Being part of changing the world is something that you can do at a startup that you can't do in a big company. Like in a big company, yeah, you can pay you really well and you can have very stable and very predictable, but it's freaking boring. And it's a knife fight for performance reviews. It's just like a gigantic dystopian wasteland in practice, in my experience. And so, like, you can learn a lot. You can be around a lot of smart people. But if you're at a company that has more smart people than hard problems to solve, it turns into a mess, right? And so, and to your point about startups are where you can have the most impact. I mean, it's the place you can grow the fastest. You can get exposed to things that are changing very rapidly. You're around people that are hungry. because people are selecting where they're going based on their own life goals, right? And so a lot of it is explaining how you can succeed and grow and scale at the company and actually be part of something that's much bigger than any one of us.
Thank you. I'll ask, we have about 3 more minutes. I want to ask one question that is kind of on general population's mind, and I want to hear how you think through it, is this Stargate announcement. So $500 billion investment go into a company. I assume it was shared in the Slacks and the various teams you're on. How is it received by you and your team? Like what do you do when you hear information like that as a leader?
I'm not the biggest fan of some of this stuff, and it's really hard to know what to believe. And so I think some of it's been debunked, and there's actually a company, but it's not actually fully funded. It's hard to really, and people are accounting for things that are actually going to other places, so it's kind of hard to know what to believe. I think there's this question, which goes back to the theme of the conference to a certain extent, which is, do you need 10 million GPUs in one system to actually succeed, right? And so it's not clear to me, right? And so what I've seen is that during the push from GPT-3 to GPT-4, for example, it was a massive leap, right? That was a massive leap in performance of the model, enabled new capabilities and things like this. GPT-5 never came. Right? Well, why? Lots of speculation. Was the data limited, et cetera, et cetera, et cetera. Well, when that was going on, I had this major question, which is that when GPT-5 comes out, if it does, if it costs 10x more to run, is it actually a replacement for GPT-4 or not? Right? And to me, I think that anything that requires a 10x higher cost differential, and so we're seeing this now with the repeated inference reasoning models and things like this, each of these models end up, in my opinion, being like a new kind of product that now needs to find PMF. Right? And so as you're defining these situations, like each of these innovations, which are, to me as a nerd, are extremely cool, each of these innovations has to prove itself to have value that can pay for itself. And so if you spend 100 million GPUs training a model and it costs like $100 billion to run the model, well, we'll see what that actually leads up to. But I don't know. I mean, to me, I think it's the old game of like the incumbents trying to like dominate and be untouchable and trying to play these games, which are really not about innovation. It's more about telling stories. That's my opinion.
Just a quick thought about that. I think the rate of change in this industry is so huge. It's not like looking out today, everybody has a very similar phone, very similar laptop, right? Very thin laptop that opens up, you type a certain way. With AI, the models are changing. Every day there's a new model announcement. We used to have 405B, Llama 3. Now it's 70B 3.3 is just good, but now DeepSeek is like 4. I mean, it's much better quality than 3.3. I think this kind of announcement is interesting, and it tells you where we are placing our values. But I think to actually, the amount of time it takes to get something done here, things might be very different in a year now because of the rate of change in the industry.
I mean, I fully agree with what both of you said. What I would add to that is, and I'll be very specific, right? This announcement came out on Tuesday. My team huddled on Wednesday. We talked about how do we participate, right? Even if we can participate in a fraction of a % of this $500 billion, that would be huge for us and probably for anyone in this room. And I'm at least a proponent of, yeah, I'm here because I'm championing an alternative view of the world, but I also know that to change the system, often it's easier to do it from the inside than shouting at the top of your lungs from the outside. I choose to do both. And so in this particular case, we analyzed, okay, it's probably going to be 9 million chips, right? Because 80% of most compute deployments are the chips, and then 10% is data center, space, and power, right? And then you have the remaining 5%, right? And 9 million chips, TSMC can only make 4 million. There's a constraint there per year. They're not going to get all of them. That probably means there's spillover effects to companies like yours because not everyone wants to be 100% NVIDIA, right? They don't want that idiosyncratic risk. And so it led us to start thinking, okay, what is our entry point into adding value to this thing? Because yes, those are the people that are in control, and let's get a seat at that table. Ultimately, I think it's, going back to the comments I was making, those folks are operating under very similar constraints as ours. They just happen to have a lot of resources. They are starting to dominate the mind share, and that's something that if we let that keep happening, it makes it infinitely harder for any of us to break out. And so we have to start working towards that mind share, which is why I think Musk was very quick to critique, and I won't go into all of that, but he was dominating mind share, then they started doing it, and he didn't want to lose that. Well, we want to get a share of that mind share, and that hope that share grows over time.
First, I have to say I love the drama among tech bros. I was loving it. I was like Twitter, looking at like Kevin Baker from chimed in, and oh, this is awesome. So I was like, I was really 100% on my plane, just going through all the tweets. It's awesome. So that aside, I feel like definitely people are creating this big FOMO, right? So if they are doing this, they're a consortium, and someone else, right? The competitors from data center, from hyperscalers, other countries, everyone's major FOMO, right? Going to see a huge wave of investment. To everyone's point, that's a different signal to economy. We're still big part of the economy. It's a huge boost in the confidence level in the U.S. economy, which is what Trump wants, right? Believe it or not, number two or not, it's going to boost everybody's, in general, emotion and optimism for tomorrow, and that will help things to evolve, right? So I think the bigger inflation, interest rate, everything else, for investment play with everything else, yep.
Cool. Thank you all. That's time, but I appreciate